Welcome to POE Thermodynamics Practice Problems. So here we have a block of aluminum at 80 degrees placed in 1 liter of water at 25 degrees. Calculate the energy transfer to the final temperature becomes 30, and then calculate the mass of the aluminum. So the first thing you have to do is write down your values of what you know. Let's make a list of our values. Okay. So our initial are both neither, and our final temps. All right, let's put in what we know. So the temperature of the aluminum initial was 80 degrees C. Temperature of the water initial is 25 degrees. This is 80. That's an 80. All right. The mass of the aluminum, we don't know. The mass of the water is 1 kilogram. Tells us that right there, 1 kilogram. Our energy transfer Q, I'm not sure what that is. We got to figure that out. That's what we're solving for right here, energy transfer. All right. What is the specific heat of aluminum? All right, so looking at specific heat on a line, we find out that it's 900 joules per degree Celsius. And the specific heat of water, we know, is 4184. Again, those come from just charts on the internet. And that's going to be Celsius. Right. And final thing, what's the final temperature of the aluminum? Aluminum final is, we know it's going to be 30 degrees Celsius. It says that right there. And of course, the final temperature of the water is also the same. All right, so those are our known values. Let's look at our formulas, what we're going to be using. So for the transfer of energy on our chart, we're going to be using Q equals MC times the temperature change. So let's write that down. We know that the change of our heat transfer needs to equal 0. Because whatever happens, you can't gain or lose any energy. It has to go somewhere, so all the heat is going to go somewhere, which means that the change of the water energy is going to be added to the change of the aluminum energy, and that should equal 0, assuming that we don't lose any heat to the air. So we're just going to assume that. Okay? And let's make sure, let's solve for, try to figure out what the energy transfer of the water is. So we'll move the Q of aluminum to the other side, and we'll start with that. All right, so let's solve for A. Part A up here says calculate the energy transfer if the final temperature becomes 30 degrees. So we'll come down here, and we're going to use the formula that I pointed out on your sheet. So the the energy transfer of the water is going to be equal to the mass of the water times the specific heat of the water times the temperature change of the water. Let's substitute what we know. We have 1 kilogram of water. Specific heat of the water is 184 kg times C over J. And the temperature change, well, we started out at 30 degrees Celsius. We ended at 30 degrees Celsius, and we started at 25 degrees Celsius. So really, that's just going to end up being a 5. All right, multiply all that out. And the energy transfer of the water is going to be 20,920 joules. And how do we get joules? Well, if we look up here, our Celsius is up in the air, so those are going to cross out. Our kilograms are going to cross out, and that leaves us with our joules. Okay? So now that we know that is how much energy went from the aluminum into the water, okay, because they're equal. Whatever energy comes out of the aluminum has to go in the water, so that went into the water. So let's solve for B. Now that we know Q, we can figure out energy transfer for B. So we have same formula, equals minus Q of the aluminum. And we know what one of them is going to be. Let's put everything in there. Equals minus mass of the aluminum times the specific heat of the aluminum times the aluminum final temperature minus the aluminum initial temperature. Right? Fill in what we know. We know the energy transfer was 20,920 joules. That came from right there. And that's going to equal minus, we don't know the mass of the aluminum, but we do know the specific heat of aluminum is 900 joules per kg Celsius. And we know the temperature change was 30 degrees at the end, minus 80 degrees in the beginning. Okay, let's do a little math. We end up with 45,000. Multiply these together. You get 45,000 joules per kg. All right, and we're going to move this to the other side, so that's going to be MA to make that positive. That's going to equal 20,920 joules. All right, now why do we lose Celsius? Right here, you got to cross out the Celsiuses, so we don't have those going with us. All right, now we need to get the MA by itself, so we're just going to divide both sides by 45,000. 45,000. Okay, let's do some, this will cancel itself out. Look over here, the joules are going to cancel out, so that gives us kg equals mass of the aluminum. Divide that out in your calculator, and you get 0.465 kilograms is going to be the mass of the aluminum. All right, problem number 2, 250-gram piece of copper metal at 100 degrees is placed in a 0.8 liters of water at 22 degrees. What is the final temperature of the water? All right, again, let's write down our values. All right, it's the things that we know. So our initial, our both or neither, and our final. All right, I'd like to make a little chart. So what's our initial temperature of the copper is 100 degrees. The initial temperature of the water, right, water initial, is 22 degrees Celsius. The mass of the copper is 0.25. We got to change it to kilograms. All right, so that's where grams to kilograms. Our mass of the water is equal to 0.8 kg, 0.80 kg. And then we have the specific heat of copper is 386, very different from aluminum. And that's joules kilogram times Celsius. And specific heat of the water is 4184 joules kilogram Celsius. All right, so we know that. All right, what we need to know is the final temperature. Temperature final. Okay, and that is going to be equal to the temperature of the copper and the temperature of the water. All right, so when you put those together, that's going to be the final, because everything's going to be the same temperature. All right, just like before, energy transfer needs to be 0. We're assuming that all the heat in the system stays in. We don't lose any to the atmosphere or the air or anything around there. Okay, so that means that the energy transfer of the water plus the energy transfer of the copper is going to equal 0. And if we're going to be solving for one of them, let's move for just fun, the copper to the other side. All right, let's start doing some solving. This time what we're going to do is we're going to use the whole formula. It's on our formula sheet right there. We're going to use that for both sides. So mass of the water, specific heat of the water, times the temperature change of the water is going to equal minus the mass of the copper, specific heat of the copper, and the temperature change of the copper. Okay, I'm going to try and keep my equal signs in the middle as we go back and forth. All right, So mass of the water, let's spread this out. And we actually have the temperature final minus the temperature of the water initial. Well, that should be a W there. It's going to equal the mass of the copper, specific heat of the copper, the same thing. Temperature of the copper final minus the temperature of the copper initial. So I like to kind of write it out so I know where to stick all my numbers. So let's fill this in. So we're going to have 0.8 kilograms of water. Specific heat of water is 4184 joules kg times Celsius. And our temperature change was water final minus 22 degrees Celsius. It's going to equal, oh, my equal signs are moving, that's okay, 0.25 kg of copper times 386 joules of copper times temperature final minus 100 of copper. All right, we got a whole lot of stuff, so let's start crossing some things out. So we can go through here. All right, we can cross out kilograms because those are going to cancel out. And let's start doing some multiplication. Okay. We're going to multiply these together and we're going to get 347.2. That's going to be joules over C. And we still have the original, or the final temperature of the water minus 22. And that's going to be equal to minus 96.5 joules over Celsius times the temperature final of the copper. Oh, forgot my little C up there. Minus 100 degrees Celsius. Okay. And then what do you have to do next? We're going to distribute this across. So we're going to get 347.2 joules Celsius, all right, times the final temperature of the water minus 73638.4 joules. So I multiplied that times this, multiplied that times 22. That's how I got 73,000. Do the same thing over here, distribute. We're going to get minus 96.5 joules there, plus the temperature final of the copper, plus 9,650. So I multiplied the 96 here times the 100 to get that. All right, and that's going to be joules because the Celsiuses are going to cancel out. The Celsiuses are going to cancel out. All right. Now what we want to do is we're going to move the 96, so we're going to add 96.5, add 96.5, both sides, they'll cancel out, and we're going to be left with 343.7 joules there, so we add those together, minus 73638.4 joules. That's going to be equal to 9650 joules. Oop, forgot. I'm going to be adding those together. I messed up. This doesn't go here because this follows over there. Yep. Sorry, I messed up. This parentheses is not supposed to be there. So there, that's supposed to go over here. So those go together. All right. Work this out. We add 73,638.4 to both sides. All right, those cancel out. And then we divide it by that, and we are left with 24.2 degrees Celsius as our temperature.